can you confirm the theory of ray diagrams matches the reality of them? So what was the theory we learned? Let's look at this one here. We learned that if a ray goes in parallel to the principal axis, please use that line. Don't try to guess parallel. The principal axis, it goes through the focus, and darn well try to get right through the center of that focus. It matters. These are scale diagrams, they're not sketches. So that's ray 1 would behave like that. The corollary of this ray, or the opposite, would be a beam of light that happened to pass through the focus will leave parallel to the principal axis, and it will go out here somewhere. So the beams of light recollided here, leading us to a condition that this mirror should be producing an image of the arrowhead down here. All the light started at the tip, and the light that left the tip reconverged again out here. If this mirror continued, continued way up here, we could assume that a beam that left the tip of the arrow on that angle would be similar or the same as if it came from the center. But the mirror doesn't go that far, and you can clearly see it is not going to line up. Why is that happening? No curved mirror should be used in its full extent. If you look at this one and you try to imagine the curvature it was taken from, this is an 80 millimeter diameter, or sorry, radius. This means it came from a circle 160 millimeters across, which is this big. From here to here, almost the entire field of view on this camera would be the full-size circle this came from. So we can track these two rays, and they should form an image there. Are we correct? Well, let's do this. We'll put in a single slit. Put this here. If you set this up correctly, the beam comes back on itself, see? Now that the beam has come back on itself, we can check the other areas. Look at that. Look how close. The drawing line I did is actually probably more accurate than the ray box because it's fanning out. But there it is. Falls right there. And if I attempt to put one in at this sharp high angle, it's almost missing the mirror. So I'm going to just cheat and pull the mirror down a bit. There it is there. It's going out the right way. Now let's demonstrate with rays we didn't even trace which other ones would work. So I'll set this up here again and watch. Any beam that passes past that tip is winding up down here. Do you notice that? No matter the angle I turn,